Okay, for geometry, lesson 6.2, this is talking about properties of parallelograms. So we've already learned a little bit about different polygons, but now we're going to specifically look at parallelograms. So I'm going to zoom into this one so you can see it a little bit better. It didn't copy very dark. Sorry about that. So first of all, if a quadrilateral is a parallelogram, so the word parallel is actually in the word parallelogram. So what that means is all two opposite sides are parallel to each other. So BC is parallel to AD, and then AB is parallel to DC. So again, if a quadrilateral is a parallelogram, then what we know is its opposite angles are congruent. So angle B would be congruent to angle D, and angle A would be congruent to angle C. So again, if the two opposite sides are parallel, making it a parallelogram, then the opposite angles are congruent. Okay, the other thing you should know is if it is a parallelogram, meaning opposite sides are parallel, then the consecutive angles, and by the way, consecutive means right next to. So if this is a parallelogram, consecutive would be, I shouldn't have done that, 1 and 2. So consecutive would be adjacent, like right next to each other. So 1 and 2 would be consecutive, 2 and 3 would be consecutive, 3 and 4 would be consecutive, 4 and 1 would be consecutive. So the consecutive angles are supplementary, which means they add up to 180 degrees, if you need a quick review of supplementary. So A plus B would be 180, that would be these two angles. B plus C would equal 180. Angle C plus angle D would equal 180, and angle D plus angle A would equal 180. So we now know some really special things about parallelograms. Consecutive angles are supplementary, and opposite angles, opposite diagonally from each other, are congruent. Okay, let's take a look at this lamp. So what it wants to know is it wants us to find the measures of P, Q, and R. So PQRS is a parallelogram, and this should have continued to go down here and point. This tiny little angle S measures 64 degrees. So if this is 64, then that means angle Q would also be 64. And if this is 64, then its consecutive angle, which would be R, has to add up to 180. So 180 minus 64 is 116. So R and P, because they are opposite, R and P are 116 degrees. Okay. Let's look down here at ABCD. It wants us to first find the value of X, then find the value of Y, and then find all the measures ABCD. So we need to find X, Y, and then ABCD. So here's what I would look at. I know that B is congruent to D. So these two, I had to make an arc a little bigger, but they are opposite, and this is a parallelogram. So these two can be set equal to each other. So over here, let's set 3x equal to 4x minus 21 because they are congruent, so they equal each other. So I'm going to subtract 4x from both sides. That would be negative 1x equals negative 21. Divide both sides by negative 1. That would be 21. So x equals 21. And you know what? If x equals 21, let's go ahead and find what angle B would be. So 3 times 21 is 63. If this is 63, then down here this is also 63. So B and D would be 63 degrees. All right, we could just subtract 63 from 180 and go ahead and get A and C, but we're also going to have to find what Y is because it wants us to find the value of Y. So let's go ahead and set 3Y equal to Y plus 78. So 3Y equals Y plus 78. So I'm going to minus 1Y from both sides. That would be 2y. Divide both sides by 2. 78 divided by 2 is, oops, sorry, 39. Oh, not degrees, just y is just 39. So y is 39. And now let's go ahead, because consecutive angles add up to 180, they're supplementary. So 180 minus our 63 is 117. And we could have done this a few different ways. We could have gone ahead and subtracted from 180, which is what I did. Or knowing that y is 39, I could have just done 39 times 3, 39 plus 78. Okay, let's look at the last page we're going to do. So our last theorem about parallelograms is talking about its opposite sides. So if opposite sides are parallel, which makes it a parallelogram, then opposite sides are the same length. So AB would be the same length as CD, and congruent, segment AB is congruent to segment CD, and segment BC is congruent to segment AD. Okay, so knowing that opposite sides are equal, are congruent to each other, it wants us to find the value of y in this picture and find the value of x, in this picture. So, and those are hard to see, but those are pluses. This one's a minus. All right, so opposite sides are equal. So we are going to set up, I would set up 3x plus 6 equals y plus 4, but those are two different variables, so we can't start there. So instead, let's start with this side equals this side, because we can figure it out if they're both the same variable. They're both y's. So let's find the y first. So 2y plus 2 is equal to the other side, 3y minus 9. Okay, I'm going to subtract 2y from both sides. This is not the only thing you could have done first. So you go ahead and solve it your way, and I bet you get the same thing I do. And then I'm going to add 9 to both sides. I'm trying to write really tiny because I'm starting to run out of room. Y equals 11. Okay, y equals 11. So actually what we could do is we could go ahead, and if y is 11, we could go ahead and say, well, 11 plus 4 is 15, which means that this side must also be 15. And it's good that we know that, because in order to find the value of x, I know that 3x plus 6 equals 15. So that's how I'm going to set it up. 3x plus 6 equals 15, and that is going to help me find x. So I would minus 6 from both sides. 15 minus 6 is 9. Divide both sides by 3. X equals 3. And then it goes on and says, now find the actual side lengths. So luckily, we already found that these two side lengths are 15. So AD and BC are 15. AD and BC are 15. And now let's find these. So if y is 11, we can say 2 times 11 plus 2. So that's 22 plus 2. 22 plus 2 is 24, and that means this side also has to be 24, because opposite sides are equal to each other. Okay, in this last one, there's one more, actually, not yet. We'll do this one first, and then there's one more theorem 6.6 we're going to learn. Okay, so this problem just says find the value of all variables. So we need to find f, e, and c. All right, here we go. If this side length is 8 and it's equal to this side length that is f minus 3, then in order to find f, we set them equal to each other. So let's do f minus 3 equals 8. I know you could do this in your head, but I'm just showing you how to work it out. So you would add 3 to both sides to get that f must equal 11. So there's one of our variables. F is 11. Let's see. We know that these two add up to 180. We also know that these two are equal to each other because they're opposite. So I'm going to start there. 102 is equal to c over 2. So 102 is equal to c divided by 2. So in order to find c, it's being divided by 2, so I'm going to do the opposite and multiply by 2 on both sides, and that would be 204. So c has to equal 204. All right, and then the last one we need to find is e. So I think I'm going to use that these two add up to 180. They're supplementary, so 102 plus 6e. 102 plus 6e equals 180 because they are supplementary. They're consecutive. Okay, so I'm going to subtract 102 from both sides first. 6e equals 78. Divide both sides by 6. 78 divided by 6, oops, turn it on, is 13. So e equals 13. Okay, we have now solved for all of the missing variables. And now our very last problem has a new theorem talking about the diagonals. So, and I have no idea why this did not copy. Sorry about that. These are supposed to be two parallelograms. And in a parallelogram, the diagonals, which are these that you can draw diagonally from each other, A to C and B to D, bisect each other. So let's think about what that means. If AC bisects equally BD, then that means wherever they meet, it separated this little mini segment and this other little mini segment into equal parts. Exactly. And same thing with the other diagonal. Where the center point is, it would have made equal segments from B to the center, which is E, and from E to the other corner, D. So the diagonals in a parallelogram bisect each other perfectly into halves. Okay, knowing that, let's solve our last problem of the day. It wants us to just find all the variables. Okay, so we're talking about x and y. Well, if we know that this would be the same length as this because its diagonals equally bisect each other, then that means that 2x equals 4. So if 2x equals 4, I know you can do this in your head, but I'm still going to show you how to work it out. X would be equal to 2. And then these diagonals also bisect each other. So y minus 1 would be equal to 2y minus 7. Y minus 1 would be equal to 2y minus 7. All right, so let's just solve that. I'm going to minus 1y, minus 1y. Negative 1 equals y minus 7, so we're going to add 7. Okay, so y would be equal to 6. All right,